Hello, everyone. My name is Emily Guidry. I'm here with Ken Ng, and we are talking today about the Ecosystem Support Program. Next slide. So ESP, we'll be using this acronym a lot. It stands for Ecosystem Support Program. I just want to make that extra clear because I got confused about this when I first started working at ESP. So in this talk, I'll be running through who we are, what we do, why we do it, and how we do it. Before I talk more about ESP, I want to zoom out and speak a little bit on the Ethereum Foundation. So the Ethereum Foundation's mission is to do what is best for Ethereum's long-term success. And some of the ways they do that is by allocating resources to critical projects. They are striving to be a valued voice within the Ethereum ecosystem, and they advocate for Ethereum to the outside world. So ESP is the resource distribution arm of the EF. So we are one of the ways that the EF pursues that first goal of allocation. Our goal is to make the EF's resources accessible to everyone in the ecosystem, not just the major players. So no ask is too small. We're really just trying to make sure that anyone who is interested in contributing to Ethereum can, like there's no barriers or anything like that. It's a shift in framing from the old EF's grants program, so our former like just EF grants, which was really focused on like what should or should not the EF fund. And now with ESP, we really believe that every project should be supported. It's just figuring out how and what form that support can come. And we holistically identify the needs and challenges of each team and really try to leverage all of the EF's resources to make sure that your project can succeed. So to be more specific about what the ESP does, we connect individuals and teams at any stage of development with a broad ranges of support. So that can mean grants, like a traditional grant, technical feedback, introductions, free access to tools or platforms like AWS credits, or we even just like engage in friendly conversation and give your team a nudge in the right direction. So let's talk about some stats, like what has ESP been up to since the start of 2020? So since the year began, we have supported 68 different projects. And again, by support, I mean all those different options, not just traditional grants. And 42% of that 68 were traditional grants, whereas 57% were alternative forms of support. So I took all the instances of support that we provided in 2020 and divided it by project category to try to show you, what are the types of things that we've been supporting. So community and education, developer experience and tooling. We've got layer 1 and layer 2 projects, user experience, cryptography and zkP, indirect funding, and other, which are all the bits and bobs that don't quite fit nicely into these nice categories. So I'm actually going to hand it over to Ken, who's going to talk about how you can apply to ESP.
Thanks, Emily. I'll run through the application process a little bit. So this is a nifty little map about the application journey. It begins with the website. Very simple. It's just esp.ethereum.foundation. So we are ESP and we're part of the Ethereum Foundation. That's how you remember. If you go to the bottom of the website, there is a contact us form. And really, this is where all of it begins. This is the beginning of the pipeline where really we want to get to know you, right? This is a conversation about what you need and how we can help you. So in there, you'll find two different links. One is for a specific project where you already know what you're working on and you just want help from us or anybody in moving that forward. The other one is exploring possibilities, where you might not know exactly what you want. You might just be an interested person who wants to dive into Ethereum, but just don't know what the next steps are. Or you just finished had a hackathon and you had so much fun and now you really want to dive into Ethereum, don't know what to do. We're here for you. The next step after you've submitted an inquiry, or you've been to a website and now you're going to submit an inquiry, we'll talk about what that is really just the beginning of the conversation, right? We'll talk through kind of who you are, what your project is, or what you're thinking about. And just to be very explicit here, this is not an application. This is just an inquiry form. We really do genuinely want to get to know you, want to get to know the project, and try to understand how we can help you move forward. The questions here are super vague. It's a super short inquiry form. The idea here is not to make this a long, tedious application where you have to spend weeks on kind of making everything perfect. A lot of times people apply and they have typos. That's perfect, right? We want to make sure that the barrier to entry is super low. Anyone and everyone can apply here. But we do want to make sure that the information we're putting there is enough for us to kind of have a conversation. So here's a little example here. I took this from hack.wtf.eth2. There's a bunch of different bounties there, or ideas of how to get started in eth2. Check it out if you want to. But for that, I picked just one thing in there. That's my project name, super generic. The project description, very clear about what it is that we're building, what we want to do, and what we think success might look like for us. You don't have to get that descriptive if you don't want to. But for this team specifically, because there is an open bounty there, there is an idea of what success looks like. For the team profile, it's just me, who our team is, yeah, that's super simple. So the next step is the intake and initial review. With that, we really try to understand from our perspective how we can actually help. So for the initial review, we really want to know kind of what challenges your project is facing. Specifically, what do you think you might need to address these challenges? What stage is your project in, right? Are you currently is it just an idea? Is it proof of concept? Have you already done a lot? Have you already have made notable milestones, or reached notable milestones, or already have funding? Have you already sought feedback from us, the community? Any of these links are really helpful for us to have a starting point to have this conversation, right? So in the example here, the needs and challenges, very explicit about who we are, what our problems are, and how we want to move forward. In this example, I'm a student who lost my internship because of COVID. Now we just want some funding to spend our summer doing something really cool. And now we take that in, we have our conversation, and we try to work together to really have an idea of what these support opportunities might be. So now we talk about how can we help. So we want to upend a little bit what support really means. I think in the rest of the ecosystem, support is solely in kind of financial support and understanding how a team may and may not be able to fund your project. But for us, for ESP, we want to kind of change that up a little bit, right? We want to look at this more on the social impact side of, really kind of have open source software traditionally roles, which is understanding not just how you can use resources, but what those resources are and how they're best suited for your challenges, right? Is it that you need coordination across different projects? Have you done this and there are other teams working on similar things that you want to collaborate with? Do you need credits? Maybe it's AWS credits, Google Cloud Services. Do you need alternative sources of funding? Because maybe EF is not right for you. Maybe you need something more from OTF or from any other of the open source software foundations. Or maybe we are right for you and we can provide financial grants as well. Do you need idea validation? Do you need project validation? Do you need mentorship? Do you need feedback from other people? We're happy to make the introduction for you. Happy to make sure that you feel empowered to have these conversations. So we'll dive a little bit deeper into the financial support process as well. This is more similar to our traditional grants process and how we have done things in the past. And we really start with the question: do you really need financial support? Is this really what you want? And is this from us? We'll provide you with a formal application link that really just provides the bare bones skeletons of your roadmap, your budgetary requirements, understanding what it is that you need to build. And so once that's done, we take it, we do a collaborative review. So same thing as before, we talk together. This is still a conversation. And really try to understand kind of what it is that you want to accomplish. We do a breakdown in the milestones. We do a breakdown in what exactly you hope to accomplish each step of the way, what the end goal is, and what the impact is going to be for the Ethereum ecosystem. After internal review, there'll be a couple of back and forths, or maybe it's super easy and there's only one back and forth, and maybe there's nothing. But a decision gets made on financial support. what to expect when you're expecting a financial grant. So with the financial proposal, as I mentioned before, diving a little deeper in, it's talking about your team structure, your qualifications, your project details, the impact, proposed impact, use of resources, and what resources exactly those are. In this, it really is kind of talking about not just the financial support, but what else you need in order to accomplish these milestones that we mentioned. And then we review and refine this, right? It's not just us, we'll do a technical interview, but we also include other people from within the EF, but also outside the EF, subject matter experts that are more able to answer the questions and help you kind of scope out what your project should do in order to maximize the impact of your project. We talk about the overall roadmap, each milestone to make sure that every step of the way we're accomplishing something that heads to the end goal, and really articulating what those goals are, not just for the entire project, but also broken down into bite-sized chunks so that each milestone really does bring you closer to that end goal. The internal review and decision process, as I mentioned before, helps to define what the funding structure is going to look like. Is it all the milestones? Is it some milestones? We talk about the project, the progress evaluation criteria when we do check-ins for the grants, the milestones, and what this timeline is going to be. Maybe it's not the full 3-year timeline that you expected, but maybe we put that into 6-month chunks. And then we also have expectations for the use of the funds. And now hand it back to Emily to talk about who should be applying.
Yes, thank you, Ken. So who should apply? Anyone can apply, but we really are looking for developers, researchers, academics, community leaders, and just anyone and everyone who is interested in contributing to the growth of Ethereum. So going back to what Ken was talking about with traditional grants, like who is eligible for that financial support? We have some minimum requirements that we expect your project to meet, which is it must be open source, it must benefit Ethereum, and it must focus on either universal tools, infrastructure, research, or common resources. We do have some big no-nos, especially when it comes to financial support. And even alternative forms of support. So we're not going to pump your token. We are not going to invest in your new quant fund or algo fund, and we are not going to fund your not related to ETH business. So if you need a little more inspiration, you're like ready to apply, don't know what you want to work on, need some ideas, you can head to our website. Again, that's esp.ethereum.foundation, and you can click on the links at the top for our wish list and our pin board. Our wish list is just a list of things that we are interested in seeing applications related to. There's just more information if you click each of those links. And our pin board is a series of interesting projects put forth in conjunction with the ETH2 team. So if you want to tackle some harder problems, go take a look at our pin board. So yeah, get in touch. Tell us what you're working on. You can, again, go to our website, or you can email us, esp@ethereum.org. You can tweet at us or follow us at ef_ESP. And if you go to our website, you can also find a blog that tells updates on just what we're up to, what our teams that we've supported are doing. And you can also sign up for our newsletter so you never miss an update. And I think that's it. Thank you guys. And we hope to hear from you soon.
Thanks, everybody.
Thanks.
Bye.
Guys, Terence from Prysmatic Labs, super excited to be here. Thanks EDCON for having me. Today my talk is about lesson learned from Onyx Testnet. As you know, Madasha launched a couple weeks ago, and we had Onyx last week in preparation for Madasha. So this talk will discuss the lessons learned from Onyx to Madasha and some of the nice things we have implemented. So let's get started. First, I want to introduce my team. We are a team of 9. Follow us on Twitter. Check us out on GitHub. There's 9 of us. And shout out to Reddit, who just joined our team last week. And shout out to tons of GitHub contributors that we have had over the last few months. You guys have been amazing, and we wouldn't have been here without you. And if you're interested to contribute, join our Discord. We're happy to onboard you. So let's chat a bit about the history and the present on this testnet. So we started out at Ruby. So back in Ruby, it was just a local chain that simulates proof of stake beacon chain behavior. It was our earliest take on what a beacon node we it was our earliest take on what a beacon node we would look like. And there's Sapphire, which was launched last year. It uses 3.2 ETH instead of 32 ETH. And we only had less than 1,000 Genesis validators to begin with. But we started implementing APIs and we want more people to build upon beacon chains, and which such effort enabled Bitfly and Etherscan to build awesome beacon chain explorers on top. And there's Topaz, which was launched earlier this year. It was aimed to be mainnet compatible and it used 32 ETH per deposit. It has slashing, it has nice optimizations. And then there's Onyx, which was launched early June. It has been running for about 2 months and it was aimed to be multi-client compatible. It implements the latest spec and we went through a run of audit with it. So as you can see, Prysmatic Labs went from Ruby to Sapphire to Topaz to Onyx, which is multi-client compatible. And in the parallel multi-client testnet universe, there was Shalasi, there's Wheaty, there's Autono. These efforts were largely led by Alfie. And each multi-client testnet has its own improvements, and whether it's different Genesis validator size, whether it's the amount of validated team that participated, and whether it's overall robustness. And just last week, we have sunset Onyx, and we have moved to Madesha. So there's just one testnet to work with, and that is very nice. Quick look on the Onyx stats before we sunset. There was 30,000 validators. Prysmatic Labs only ran 4,000 validators, so that's about 10% of the network. And there was 300,000 slots, 10,000 finalized epochs, and about 250 to 400 peers in the network. And in the next few slides, I'll go over some of the lessons learned, what we worked on, and some of the exciting things that happened. So from Onyx to Madesha, there was tons of improvements. There was about 2 months of the time. There were about 7 releases, about 500 issues, and 500 PRs that were closed and merged. And we were able to onboard 20 plus new contributors. So that's very nice. So yeah, so let me go through some of the lessons learned. And for those that have been running a validator, right, you may have noticed that our existing key management tool isn't the best user experience. So we have been working on cleaning that up, and we've been working on a revamp of our account management. And since the introduction of EIP 2335, so what EIP 2335 is a standardized key store directory and file format across all clients to follow a similar strategy, so it may swapping keys between clients seamlessly. And we have been refactoring the key management tooling, so we're also making sure that new wallet tooling is much easier to use. And we have the following new key management type. There's direct, which utilize EIP 2235. There's derive, which utilize HD wallet. And there's remote, which utilize remote signing server via gRPC. They also integrate nicely with the E2 Launchpad. So yeah, check out our documentations. As part of our effort to revamp how key management work in Prism, we also want to sharpen our toolings as well. So in particular, many users want to run the validator client in a cloud, and they want to use a remote signing server elsewhere that's able to securely store the key and sign data as needed. So in the Prism Validator client, we have a gRPC client built in that connects security to a remote signer as desired by the user. So for reference, and we have put our reference implementation on GitHub. It's licensed under Apache 2. And also you can write your own remote signer server in any popular language that you want, which supports gRPC, as long as your server implements the required API schema for a remote signer defined in Prism. So one of the major improvements that's required to speed up chain synchronization has to do with how we verify block signatures, right? So the naive way of processing block is to perform sequential processing, check every state transition, check every signature sequentially. But every time we verify one signature, we incur a significant performance cost. So instead, we actually improve upon that. So we verify signatures in parallel. We batch verify aggregated signatures. We batch verify block proposer random signatures as well. So we'll need to verify once after a certain checkpoint. So this helped drastically improve the speed of initial syncing, and such improvement is very noteworthy. If you look at Alfred's latest report that you can see in that link over there, and with a full batch signature verification, Prism is almost as fast as Lighthouse, and we're confident that we'll continue improving this benchmark as we approach mainnet. So lesson 3, in Onyx, we have experienced volatile peer-to-peer messaging. So users were reporting high error rates in processing new blocks, and that seemed to affect the finality of the network. So we identified the root cause seemed to be that Prism client was getting out of sync and producing blocks that's older than last finalized block. So based on what we fixed, and the issues was we fixed the issue, and we have reflected that to the upstream spec as well. And another thing is rate limiting, right? So rate limiting and peer scoring refractory work has been started. So our aim is to make sure that Prism Beacon node is more robust and is capable of performing its duty in presence of slow, broken peers. So the current rate limiting system that we have is already capable of being peers that send us requests too aggressively. And we're actually extending it to be more sophisticated in a way that how good and bad peers are detected and what actions are taken to prevent such behavior. In addition to Bain, we're also diversing a reputation system as well, which will score peers based on a wide range of different performance metrics. And we'll also throttle peer that violates carefully selected thresholds. So QuantStamp is a security, the blockchain security firm has recently completed its audit of our Prism client, and it went over the course of 2 months. So QuantStamp examined our full code base for critical security vulnerability gaps in testing, and it found a few bugs were running the Onyx testnet as well. And then it also gave us great feedback on end user considerations, how to minimize security risk. So you can read the full audit report here. And QuantStamp also did an excellent job. Not only it's explaining great depth on some of the vulnerabilities, it also included a comprehensive appendix which suggested best practice to reduce further attack surface. And so upon completion of the audit, we created a comprehensive tracking issue to resolve all the items found by QuantStamp. We are 70 or 95% there on addressing all the relative issues, and we'll get to 100% very soon. So lesson number 5 that we have made monitoring is very important. We have made significant improvements on monitoring. We've added better matrix, better RPC debug endpoint, and better logins and better instrumentations. We have added metrics such as drop time, so we're able to see like when the cloud drift gets too wide between beacon node and validator client. So test coverage improvement, yes. So one of the feedback we've gotten when running the Onyx testnet is that we do lack unit tests in certain areas. So we have made improvements for the last 7 releases, and that was the before and after. And you can see that blockchain package went from 36% to 57%, and that's quite nice. And please do expect that we'll continue improving this as we get towards mainnet. And in lesson 7, in Prysmatic Labs, we love post-mortems. Whenever there's a drastic issues, we are always on top, refer to. And if you're interested, feel free to take a look. So we started thinking carefully about the biggest pain points for contributing to Prism project, and we have decided to run a small community survey asking everyone about their experience running a node, interacting with Prism, and reading our documentations. And it ended up yielding really productive results. So the biggest feedback comes from the pain of learning and using our build system Bezel. And for external contributors or that want to just use Go, that was really hard. So we actually make our project Go gettable after that. And the other feedback that was resolved around account management, which we addressed back in lesson number 1. And we also got feedback such as like people want to run any sort of iden3 node, such as Nethermind, which is now fixed in our latest branch. So overall, community feedback drives really good initiative, and the people's experience with Prysmatic Labs seems to be really positive. We're really happy with it, and but by integrating, testing, understanding its complexity, I think we can do a better job. And code health is going to be a big priority for us going through mainnet. So if you have some feedback, please do let us know. So by Onyx, now this is the last screenshot that I took for Onyx before we sunset. And as you can see, it was already, since Prysmatic Labs only run about 10% of the network, and it already had problem with finality, right? So it was about 500 epochs since finality. That's about 2 days worth of node finality. And even with that, the node was still quite stable. It was still like 2.5 gigabyte of RAMs, and then CPU is fairly under constraint. And there's no gRPC error. So we're quite happy to see that. So hello, Medesha. So this is a screenshot I took before recording this. And as you can see, Medesha has been going great. It's about 8,000 slots, 250 finalized epochs, and we only run about 3% of the network. But yeah, I'm just really happy this is going really great. So you may ask, what's next for us, right? What's next for us is that we wanna be as ready for mainnet as possible. So that includes define, satisfy beta requirements. We'll define the beta requirements. We will share the beta requirements with the community, and we'll satisfy that. And then we want to do some further audits. We want UX improvements as well. We want people to have the easiest time using our client. And as I mentioned earlier, we want to improve the test coverage, and we want to go through more rigorous integration testing. So if you're interested in any of these items, feel free to contact us. We're happy to work with you. And that's it from me. Thank you for having me, and feel free to join our Discord and ask us any questions. Thanks, guys.
Hello everyone, welcome to the Ethereum gas price markets with VIP 1559. My name is Tomasz Stanczak. I work on Nethermind Ethereum client project, and I'm excited to show you this new improvement proposal for Ethereum gas price that many people are discussing, many people are excited about and waiting for. So let's have a look what it means for all of us. Maybe before I talk about EIP 1559, I will do a quick recap of the current gas prices in Ethereum mainnet. So whenever you create a transaction, you have to set the gas price on the transaction first. And if you set it too high, the transaction will just make you overspend. If you set it too low, you may end up waiting for a long time before the transaction is included in a block. Because what miners do, they will just collect all the transactions created by you and other users of the network, and they'll put them into mempool, and then they'll sort them by the gas price from the highest gas price to the lowest. And they will create a block and include the transactions as long as there is enough space within the block gas limit. And it'll be obviously including the transactions from the highest price to the lowest, because all the transaction fees are being paid to the miner account. So they're just naturally incentivized to pick the transactions with the highest gas price. And this mechanism is called the first price auction, which means that you practically blindly keep bidding without knowing what the final price will be. And at the end of the auction, you just learn how much you paid, whether you won or not. You either not paying at all because you didn't win the auction, or you end up paying the price that you bid. And there are some problems with first price auctions. In particular, the price that you pay very often is just too high. And there's another problem with the current gas price market. When you think about it, maybe it's a bit less clear, but it's really hard to tell what the real gas price on the market is. And why is it so? Mainly because the miners are allowed to include transactions in the blocks which are their own transactions. There's really no way to forbid that from happening. And the thing is, whenever they include those transactions, very often they will include them at zero price, or if they want, they may include them at arbitrarily high price, which means that if you ever try to rely on the gas prices from the block, you may simply have it all confused because of the miner transactions. And whoever tries to set the gas prices for the transactions they create very often will choose some kind of average from the previous blocks, which again might be distorted by the transactions from the miners. And since the transactions that they create, the signers of the transactions are not priced properly, everyone else is like misled by those hints from others, and everyone is either overbidding or bidding not enough, making those mistakes, and hence we simply cannot tell what the real gas price on the market is. So here comes the EIP 1559, and it tries to solve the problem by introducing a set of parameters. Probably the most important one is the base fee that's added to the block header. This is something that fluctuates between blocks and is calculated by protocol. And apart from base fee, which is a minimum gas price that has to be paid for all the transactions that are included in a block, we have a gas premium, which signers of the transactions add to the transactions themselves. So they work very similar to what the current gas prices do. So they work as a tip to the miners. So if the more you pay as gas premium, the more likely the miner will prefer your transaction over others. And then there is also fee cap. So this is like the second part of the current gas price model, which is limiting how much you will pay for the transaction. So fee cap just says whenever base fee plus gas premium is above the fee cap, I'm not really approving to pay that much. So I'm just not approving that base fee. And even like if you don't set gas premium, then if the base fee is above your fee cap, you will just not accept the transaction to be included in a given block, and you'll wait for the better times. The block gas limit itself remains voted on by the miners. However, we changed slightly that meaning of the vote. So we no longer vote about the absolute limit of the block. We vote for the target. And the target means that we can create blocks that are up to 2 times the size of the target. As for the base fee adjustment mechanism, it's all based on how big blocks are being created on the mainnet. So if the blocks created are the perfect size in a way, so they match the target gas limit of the block, let's say 10 million, and then the base fee will remain stable. If the blocks created are bigger, up to 2 times bigger, then the base fee will be rising. It means that we actually want less people to post transactions and less transactions to be included in blocks. So we just raise the base fee until we get to the desired block gas limit again. And if the blocks are created on the network which are empty or simply below the target, then the base fee will fall, and it will encourage more users to post transactions now because there is some extra capacity. We are below the target. We want the blocks to be bigger. One important property of EIP 1559, which many people are excited about, is that we're burning the transaction fees. So what is defined by base fee will be burned, will not go to the miner. And that's super important from the perspective of what I mentioned before, which is preventing the ability of the miners to manipulate the base fee price, the gas price. So they no longer can post any transaction with any gas price they want because the fee will simply not go back to them. It will be burned and it would be at severe loss. This burning is exciting people because it's simply meaning that there will be less inflationary pressure on Ethereum. Less Ethereum will be created net of rewards because some of the Ether will be burned as part of the transaction execution. As for the fees themselves, let's analyze a few scenarios. When, for example, fee cap is greater than base fee plus premium, what happens then? So fee cap practically has no meaning in such a situation. You simply say that as a signer of transaction, you find to tip miner a bit and that you'll pay whatever base fee the header has. And in such situation, you see that transaction is paying, everything is paid by signer, premium and base fee, but majority of that value will be burned and just the tip and the premium will be paid to the miner. I'm saying majority, but really the base fee can be really low and your premium can be very high. So in such situation, miner would still earn majority of the fee and only some part of it will be burned. But it really depends on how busy the blocks will be created. In the cases when the blocks are more or less empty, you won't have that much of the burning because the base fee will be very low. Then we have another scenario when actually the fee cap, while it's bigger than base fee, it's still lower than the base fee plus premium, which means that you decided to limit your the size of the gas price that you're paying below the current state of the network. So the base fee is so high that you cannot really approve covering the premium that you promised before. So some of this premium have to be foregone by the miner, and the transaction can still be accepted by the miner if they want, but the premium will be capped by the fee cap level. So still everything is paid by signer, and still very similarly we burn base fee and miner gets some part of the premium limited by the fee cap. And the last scenario really is very interesting. Actually, it's a subsidized transaction. So you set the fee cap so low that it's below the current base fee on the market, which means that if the miners decide to include your transaction, they can still do that, but it will have to cover the remaining fee that you didn't cover. So you say like, okay, the base fee is 10 GUI and my fee cap was 9 GUI. So the miner says, that's all right, I'll subsidize the remaining 1 GUI for you, and everything will get burned, which means that the part that miner paid was burned, they subsidized it, they lost it. And we can try an example calculation of EIP 1559. So let's say the target gas used for a block voted by miners is 10 million, which means that the gas limit really on the block can be up to 2 times bigger than that, the target. And we have a very important parameter, it's called base fee max change denominator, and it defines how volatile the base fee will be, how quickly it will adjust itself if there are big variations in the block sizes. So let's work with an example where we have a gas used 7.82 million on a block, which is below the target. We set the target for 10 million and the gas used is 7.82. So we want the next block to be bigger, and to encourage that behavior, we'll be lowering the base fee. The base fee in this particular block, for our example, is 1 GUI. We calculate the delta from the gas used on the parent block that we created and the target gas used, and in our case it's a negative delta. And delta can be positive if the block is above the target, and that would change our calculation obviously in other direction. And the base fee that we calculate is a parent base fee plus the part of the parent base fee that is multiplied by, first of all, the delta, so the difference, and the ratio of the delta to the target, and then limited by this base fee max change denominator. So we just limit how quickly we move towards the target. And here, as an example, we have 0.97 GUI gas price calculated for base fee. And we can have an example of the calculation with full blocks happening on the network. So whenever a full block is happening, our delta calculation will be really equal to target gas used. And in such cases, we'll be using the entire parent base fee in the second part of our equation, and we'll be moving by the denominator at every single block. So 1/8 of the parent base fee change every single time. So we see here after 8 blocks, we reach the level of 2.28 GUI, starting with 1 GUI. Let's see the opposite scenario. So the blocks created are empty. The delta in such case will be negative. Negative at the level of target gas use, which makes the second part of the equation just -1 multiplied by the max denominator, so the max move, max adjustment. And again, we'll see after 8 blocks, we reach the 0.34 GUI, so it's around 60% below the starting point of 1 GUI. Now we see the last possible scenario that is interesting to look at. The blocks are actually at the desired size. So all the blocks are created, as in our case, at 10 million. And it means that practically we don't want to change anything. So the base will be stable, will not move. Every single block will be at 1 GUI. Now, why I think that EIP 1559 is particularly exciting for the gas price markets. So most important thing for me is that the base fee will be observable on chain. So something that you really don't have access to at the moment from the perspective of the virtual machine will be available for any smart contracts. And we started working on a product that is creating some kind of hedging scenarios that are based on the observable base fee. So you can take into account the gas price that can no longer be manipulated by the miners. So in the past, if we would like to post information about the gas price to the smart contract, it might have been just totally manipulated. If you build any product on chain that would try to react to the gas prices, anyone would be able to trade against it and manipulate the market if they were, any miner would be able to manipulate the behavior of that smart contract. This is no longer possible, and this is super exciting. So obviously, just the basic goal of the introduction of EIP 1559 happens as well. So we should see much less volatility of gas prices, much more predictability. People will be able to know what exactly the direction of the gas prices is recently, and use the wallets, adjusted wallets UIs to have a bit more of a more likely have their transactions included around the actual gas price as it is on the market. Thank you so much for listening, for staying with me, and there are plenty of links available online that can give you much more details about EIP 1559, so have a look at the IP itself, about the discussion around the inefficiency of first price auctions, the Controls here is a behavior of the systems, as we would like to have a system that auto-adjusts the gas price. Look at Ethereum Magicians and research for all the discussions happening there around EIP 1559. Look at the previous implementers calls where multiple ideas were discussed, discarded, or actually accepted into EIP. The fantastic simulations from some of the teams that are analyzing the behavior of the miners and market participants in different scenarios. Also some alternative solutions like gas escalator. And if you're interested in any links for the images used, they are here. Thank you so much. Thank you.
Hello, I'm Jordi Baylina, iden3's technical lead. We have an important announcement, Hermez project, which is a spin-off of iden3 identity project. Since the beginning of iden3, we tried to provide privacy and worked hard in the zero-knowledge technology. Outcome of this has been circuit compiler and Snark's implementation with Snark.js. Another objective we had is to scale self-sovereign identity in order for any identity to be able to issue claims for free. So we were building rollups, leveraging in our own background and in collaboration with other groups in the community. After a couple of iterations of a proof of concept in Guidry Testnet, we decided to launch a payments zkRollup. Hermez is an independent project of iden3, but we are using the technical and human resource to launch this project in production, expected during the fourth quadrimester of this year. So Hermez is a new zkRollup network with the initial scope of supporting Ethereum ERC20 tokens transfers at the maximum performance that the technology is allowing, and that will be increasing. We start with 2,000 transactions per second, but this will increase very much in the upcoming versions. We have two objectives in this project. The first one is to build a project which is designed with native decentralization model that will become fully decentralized at one moment, once the system is secure enough and after a short bootstrapping phase. And the second objective is to run a model which will provide value for the layer 1 and the community in general via redistributing value from the network fees. I will explain more that later in this presentation. The way that we achieve these 2,000 transactions per second is structuring the transactions received by the network in batches and generating a zk proof for each of them to be validated on the mainnet. Since we have the capability of including 2,000 transactions in a single proof, and we are able to fit 15 batches in an Ethereum block, and there is one block every 15 seconds, this brings us to the total limit of 2,000 transactions per second. A key part of our project is a model where we enable permissionless actors to construct the batches of transactions of layer 2, generate the zk proofs, and send it to the layer 1 for validating and mining. These are the miners of Hermez. We call them network coordinators. The coordinator who built the block, we call it forging, will collect the fees on the transactions on it. Coordinators, they also decide which are the most profitable transactions to include in the block. They need to keep an updated status of the network, receive transactions from the users and process them to build the layer 2 block and generate the zk proof, which will be sent to the layer 1 smart contract, which will validate the proof, and so the transactions data will be saved. So the coordinators are the permissionless agents that will participate in a decentralized auction in order to get the right to forge blocks. So how we select who has the right to forge batches? What we do is we split the time in 10 minutes slots, 40 blocks. We do an open auction to sell this slot. The coordinator that's willing to pay more in this slot will be the one that will earn the right to forge as many batches as they can. This model is intended to be open and to incentivize efficiency in coordinators. Since the bids needs to be high enough to win but keep a margin with the estimated amount in fees that this coordinator will collect. The more transactions a coordinator can forge, the more value he can collect. During a bootstrap phase, there will be a boot coordinator which will forge all slots where no alternative coordinator bid over the defined minimum price for the slots. Hermez will have two ERC777 tokens, fully compatible with ERC20 tokens. The Hes utility token will be used to place bids in the auction. There will be a market for these tokens. The security token is a representation of the network stakeholders and will be used in future DAO governance to receive a part of the value generated in the network. The objective is that these tokens become distributed as the network operates. Both tokens will be used as incentivization for the bootstrapping phase. The other new concept that we bring is the concept of donation. Hermez will donate 40% of the bids placed in the auction to fund community projects. We will start with Gitcoin quadratic funding grants, but governance may decide to include other pools as they become available. The rest of the value from the stake will be distributed between Hermez holders by burning 40% and the security tokens holders by distributing 20%. We believe that this model provides value for the network stakeholders and also for the layer 1 ecosystem. Since we are borrowing a lot of value from layer 1, we understand that Hermez needs to give relevant fraction back. I hope that this generates a precedence for the layer 2 systems to understand that it's important for them that the layer 1 keeps going, keeps improving, keeps well maintained, and layer 2 systems have this responsibility of taking care of the layer 1. And that's pretty much what I wanted to share with you today. Thank you so much for your attention and stay tuned for the updates on the project status. Next month are going to be very exciting.